Climate change is happening, whether we want to acknowledge it or not. As climate change advances, water temperature, volume, and quality changes, habituating environments that favor algae blooms. More likely than not, this issue affects you. These algae blooms, also known as cyanobacteria, are often toxic, and they disturb the habitats and ecosystems around them, putting other organisms and humans at risk for health problems, population decreases, and die-offs. This is currently a growing issue in our very own Lake Champlain.
Algae blooms from excess nitrates in water kill the animals and plants that inhabit the water, and this causes a decrease in biodiversity. It is also dangerous for humans to come in contact with. This poor water quality also affects real estate values in the area because dangerous water is very clearly not considered an attraction. Many industries require clean water like agriculture, tourism, food processing, and power plants. Without clean water, these industries will not be able to continue to function and society cannot function without them. As water quality declines, more recesses will be necessary to treat it. In order to make safe drinking water, this means taxes will have to be raised in order to regain water that is not dangerous to consume. It takes years to fix water quality, and if it keeps getting worse and keeps spreading, it will only be increasingly difficult to fix and will be an extreme burden on future generations, and if nothing is done, it will eventually become unfixable.
These are the optimal conditions for algal blooms. Algae does best in warm temperatures with no mixing and increased sunlight. Climate change causes warmer air temperatures and traps warmth on the surface of the water, which increases the amount of sunlight energy absorbed. Lake turnover is a process that happens in the fall, which causes the lake to mix, redistributing sections of different densities. Thermal stratification occurs during the summer when water density layers do not mix. Warmer temperatures cause longer summer stratification. Climate change causes less ice cover in the winter, and warmer surface temperatures and less transfer of warm energy to the bottom due to stratification. This feeds into the toxic algae cycle to allow for more cyanobacteria to persist and for increasing hypoxic conditions. Climate change has been shown to cause extreme weather events like major rainstorms and other natural disasters. This causes increased water flow and sedimentation carrying pollutants, which then lead to eutrophication. This decreases overall water quality. Phytoplankton thrive in warmer surface temperatures, but increased cyanobacteria has caused a decline in phytoplankton diversity because cyanobacteria compete and shade out the sunlight. This then causes decreased zooplankton diversity. Cyanobacteria thrive and then die at exponential rates. Decay causes oxygen depletion, which then causes hypoxia.
Vermont has a long history regulating eutrophication in Lake Champlain with regard to algae blooms. In the 1960s, the St. Albans Bay Association began using algicide, copper sulfate, as a superficial solution. However, this was more of a Band-Aid solution and did not address the underlying problems causing the algae blooms. Now we understand algae blooms as the result of excess nutrients, especially phosphorus and nitrogen, which are introduced in these ways. Besides preventing the influx of harmful nutrients in the first place, there are many solutions to controlling algae blooms. The first is aeration. Aeration pumps warm air through the sections of the water body to prevent stratification. Warm and cold water circulate in the cells instead of separating. This prevents dissolved oxygen and temperature differences, but aeration devices have limited ranges and disrupting the thermocline can be harmful to organisms in the benthic zone. Another solution is mechanical circulation, which is very similar to aeration. Mechanical circulators pump warm water from the upper layer to the bottom layer or vice versa. The benefits and challenges of mechanical circulation are the same as aeration. Hypolimnetic oxygenation can also be used to mitigate algae blooms. This is the most promising of the three solutions covered. Hypolimnetic oxygenation works by directly inputting oxygen into the hypolimnion, cold dense layer. A high dissolved oxygen concentration towards the bottom of the body reduces the ability of sediment to release nutrients. A major benefit of this method is that it maintains the thermal integrity of the water. Individuals can also implement simple solutions to reduce the problem of eutrophication. Consider the ways you control runoff from your home. Store your stormwater in a rain barrel and make sure your gutter faces a permeable surface. Think about planting native plants instead of a monocrop lawn, and don't apply fertilizers before a heavy rainfall.
Wetlands are effective in their absorption of nutrients that cyanobacteria thrive off of. One potential solution for removing and mitigating the nutrients that cause potential algal blooms is adding powdered activated carbon, which absorbs these minerals quite effectively. Unfortunately, the large amount of this carbon needed in bigger bodies of water is very expensive and therefore is not entirely cost effective. Records and data have only been collected from specific areas, so consensus regarding the correlation of climate change and algal blooms has not yet been reached. With the recent IPCC report stating that the effects of climate change will soon be irreversible, it's important that we do anything to mitigate algal blooms from forming. Frequent checks of water quality based off of oxygen, nitrogen, and phosphorus levels show us how much a waterway is affected.